Hi everyone. So there are a number of topics that we did not get to between class last Thursday and class today. For that reason, I've created a few videos for you to watch to cover the material that we didn't get to, because first of all, you need it to finish your My Math Lab assignment. Second of all, you're going to need it for the quiz. I don't have time to completely skip over this material and wait to do it until we get back. So this work, watching the videos and going through the notes for them, will replace the class that we were supposed to have this Thursday, the 20th, which I'm not going to attend. So it is very much so a virtual class. You need to watch through all of these videos, use it to help you complete the homework, and then use that to help you with your quiz. The dates of all of those are going to be adjusted a little bit, so I will send an email out with that information. This first video is going to talk about trig identities. Now, I know it's something we've touched on very briefly. I just wanted to take some time to go over it a little bit more formally and to show you some examples of problems that you might see. The first thing that you should do right now is to go on to UB Learns under Course Resources. Under Today, there is a document that says Fundamental Trig Identities. You should print this out so that you have all of these available, especially while you're working on your homework. So I'll give you a second to do that. You can pause the video if you need to go ahead and print that out, and then when you're ready, resume the video. So fundamental trig identities. The first set that's on your page are the reciprocal identities. I know we've talked about these a lot, right? We have our three reciprocal ratios, which are cosecant, secant, and cotangent, and those are each the reciprocal of one of the original trig ratios. Cosecant is the reciprocal of sine, so it is 1 over sine. Don't mind that yardstick that just fell. Secant is the reciprocal of cosine, so this is 1 over cosine. And cotangent is the reciprocal of tangent, which is 1 over tangent. So we've talked about these three quite a bit. We haven't explicitly talked about them in the other direction, right? But those are also on your sheet. They're actually on the left-hand column, where sine is the same thing as 1 over cosecant, right? So they are interchangeable. The fact that they're reciprocals means that you can interchange them with each other. We could do the same thing for secant and cosine, and then for cotangent and tangent. So those 6 identities are on your paper. I'm not going to write all of them up here because you have them. But let's look at an example problem that might be used with one of those identities. You could see something like evaluate this expression usually it'll say without using a calculator. So something like the cosine of 37 degrees times the secant of 37 degrees. And they may say, what is that equal to? Well, cosine of 37 is one of our original trig ratios. We can keep that the same. But secant, remember, secant is the reciprocal of cosine. So let's keep this the same. Secant, we can rewrite it as 1 over the cosine of 37 degrees. When we multiply these two expressions, we get the cosine of 37 degrees over the cosine of 37 degrees, which happens to be 1. Okay, so it's just taking what we already know about the relationship between some of these reciprocal ratios, right, and putting it to an actual problem. Almost all of these identity questions, your answer is going to be 1 because it's an identity. 1 is our multiplicative identity. Okay, so that's an example with the reciprocal identities. There are also 2 quotient identities, and I know we touched on this just briefly, but they are related to tangent and cotangent. Now we know that these two are reciprocals of each other, but they can also be written in terms of sine and cosine. Tangent is actually the ratio of sine to cosine for a specific angle. So when trig was being invented, right, we had a sine and a cosine curve, and they said, let's have another trig function that represents the ratio of sine to cosine for any given angle. So that is literally what tangent is. It is the sine over the cosine. And then cotangent, since it's the reciprocal, we know it's just the opposite of tangent, which is going to be cosine over sine. Okay. So a question that you might see related to the quotient identities, and I'm going to leave tangent up there just because the example is going to use it, could be something like find the exact value of, so find exact value, right? Find exact value of the tangent of theta if the sine of theta is, I don't know, radical 3 over 2, and the cosine of theta is 1/2. And you can just take those values and plug them into our equation. So find the exact value of tangent if the sine is equal to this and the cosine is equal to that. Okay, so we'd have the sine is equal to radical 3 over 2, and the cosine is equal to 1/2. Okay, a little bit of fraction work here. Radical 3 over 2 divided by 1/2 is the same thing as radical 3 over 2 times 2 over 1, right? Dividing fractions means change it to multiplication, flip the second. Our 2's will cancel, so we just get radical 3 over 1 or radical 3. Okay. You could also realize that you multiply both your numerator and your denominator by 2. And if I multiply this by 2 and this by 2, that gets rid of my denominators, and I have radical 3 over 1, which is also radical 3. So that's an example of a problem that you'll see with the quotient identities. Okay, 2 more sets to go through. Next on the list are Pythagorean identities. These actually are not written on your sheet, so you're going to need to add them yourself. The first Pythagorean identity, and actually all 3 of these really come from the unit circle, which we'll get into a little bit once we get back next week. But the first Pythagorean identity says that if you square the sine of an angle and you square the cosine of the angle and add them together, that is equal to 1. So like I said, this is related to the unit circle and to Pythagorean theorem. We can see the a squared plus b squared equals c squared going on with that. This is one very specific derivation of that. So the sine squared plus the cosine squared of any angle is always equal to 1. Okay. There are a couple of derivatives of that original cosine function, or of the original Pythagorean identity, and they come from dividing each piece by a certain value. So it's not necessarily important for you to know where these come from, but if we were to take each of these, so this is our first identity, which I'm going to rewrite. If I were to take each term and divide it by the cosine squared, well, sine squared over cosine squared, that's one of the quotient identities we just looked at. This is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine, that's one of our reciprocal identities. Okay? 1 over cosine is secant squared. So this is another Pythagorean identity. Tangent squared plus 1 equals secant squared. The third one is very similar. It just comes from dividing everything by sine instead of cosine. But what you get is 1 plus the cotangent squared is equal to the cosecant squared. And those are your 3 Pythagorean identities. Okay. So now that you have them, let's look at an example of what you might be asked about one of them. For starters, and I'm going to erase these two, so hopefully you have them written down. We're just going to use the first one for our example. Sine squared plus cosine squared equals 1. And we're going to look at 2 potential questions or types of problems that you could see from this. First, it may say, just evaluate sine squared of 98 degrees plus the cosine squared of 98 degrees. Just a regular question. You would have to notice that it is sine squared and cosine squared. And whenever we have sine squared and cosine squared and we add them together, that is going to be equal to 1. So your answer to that would just be 1. Another question, so another type of example, if we separate that, maybe find, and you know what, I'm going to, erase that, we'll condense here. Find the exact value, FEV, find the exact value of cosine theta if sine theta equals, let's call it 2/3. So here we have an equation that we can use to plug in our value of sine. Sine of theta is 2/3, so we would have 2/3 squared, sine squared, 2/3 squared, plus cosine squared equals 1. Then we can evaluate it just like a regular equation. 2/3 squared is going to be 4/9 plus cosine squared equals 1. To get cosine by itself, we can subtract 4/9 from both sides. So we get cosine squared is 5/9. Use your fraction knowledge to get that. We want to get cosine by itself, which means we need to take the square root. Okay, so that's going to bring us up here. Cosine of theta is the square root of 5/3. So the square root of 5/9, right, we could write that as the square root of 5 over the square root of 9. Well, square root of 5 is not a rational number, so we just leave it as rad 5. Square root of 9 is 3. So this would actually be our answer. Okay. So the question again, find the exact value of cosine, given that the sine is 2/3. Well, we can plug sine into our identity, do some algebra, and solve for cosine. Right? And that idea of exact value means keep it in radical form. All right, so the last identity that we have to look at, or last types of identities, are called cofunctions. And cofunctions, let me see that word, cofunctions. Every trig ratio has a cofunction that goes with it. And the piece of cofunction actually refers to the word complementary. which in trig, or when we're talking about geometry and triangles, complementary means two angles that add to 90 degrees. So if you have complementary angles, they add to 90 degrees. And we know that in a right triangle, we'll call this C, A, and B. We know that one of the angles for a right triangle is 90 degrees because it's a right angle, which is what makes it a right triangle. The other two angles, by default, have to add up to 90 degrees. They take care of the rest of that 180. So in this triangle, angle A plus angle B equals 90 degrees, which means that these two angles are complementary. Okay, so if we think about, let's start with angle A. If we're looking at angle A, this is the opposite side. This is side A, this is side B, this is side C. And this is adjacent, and this is a hypotenuse. So if we wanted to talk about the sine of angle A, that's going to be opposite over hypotenuse, A over C. And if we wanted to talk about the cosine of A, cosine of A is going to be adjacent over hypotenuse, which is going to be B over C. Then if we were to change it to B, if B becomes our new angle, these change. This is now opposite, right, if we're looking at angle B, and this is adjacent. So, if we wanted to find the sine of angle B, sine of angle B is opposite over hypotenuse, which is B over C. And cosine of angle B is adjacent over hypotenuse, which is A over C. So hopefully you can see here that the sine of A is equal to the cosine of B. They both have the same ratio of A over C. The same thing is also true for the cosine of A and the sine of B. And this happens to be true because sine and cosine are co-functions of each other. So that's where these co-function identities come from. So I'm going to write them up on the board, and then we'll talk very briefly about why those are the way they are. So the first co-function identity says that the sine of any angle theta is equal to the cosine of the complement of that angle. And the complement of theta is 90 minus theta. Okay? So whatever this angle is will be the complement of the angle we started with. In cosine, right, we know we have sine. The co-function of sine is cosine, which is short for the complement's sine. Okay? So that's why the sine of this angle is equal to the complement's sine, or the sine of the complement of that angle, is literally where that comes from. Okay, our other two ratios, or our other two co-functions, tangent goes with cotangent, right? Same idea, 90 degrees minus theta. And secant goes with cosecant, which is 90 degrees minus theta. Okay. You don't necessarily, again, have to know the rationale behind where these come from. Hopefully that example that we just looked at with the triangles helps you make sense of it. But in terms of a question, it'll say something like, use cofunctions to find an equivalent expression. Something to that effect. And they'll give you maybe the tangent of 21 degrees. And they'll say, use cofunctions to find an equivalent expression to the tangent of 21 degrees. So the way we do this, the cofunction of tangent is cotangent, so that becomes cotangent. The complement of 21 degrees is 90 minus 21. So this happens to be the cotangent of 69 degrees. So basically what that is saying is if you find the tangent of 21, that is going to be equal to the cotangent of 69 degrees. And you could plug both of those values into your calculator and you should get the same answer. Okay, another example may be something like, say they give you the cosine of 30 degrees. And they say use cofunctions to find an equivalent expression. The cofunction of cosine is sine. The complement of 30 degrees, 90 minus 30, is 60 degrees. So that would be your answer. Okay. And that covers the 4 different types of identities that we're going to be looking at for this unit. Okay, so hopefully you have that. If you need to refer back to the video at any time while you're doing your homework, you can, just as a way to help you through some of those problems. Okay.